Welcome to our journey through the solar system. Today, we'll explore the incredible planets, fascinating moons, and amazing features that make up our cosmic neighborhood. Buckle up as we blast off into space. Whether you're a space enthusiast or just curious about the universe, there's so much to discover about our celestial companions. As we travel through the solar system, we'll learn not just about the planets and moons, but also the unique characteristics and mysteries that each body holds. From the scorching heat of Mercury to the icy winds of Neptune, each planet tells a story about the history of our solar system and the forces that shaped it. Most importantly, we'll see how gravity and the sun's energy play vital roles in making life possible on Earth and influencing the potential for life elsewhere. Our adventure begins with the heart of our solar system, the Sun. This massive ball of hot plasma is about 93 million miles away from Earth. It provides the light and heat that sustain life on our planet. Did you know that the Sun makes up about 99.86% of the solar system's total mass? Without it, there would be no life as we know it. The Sun generates energy through a process called nuclear fusion, where hydrogen atoms combine to form helium, releasing enormous amounts of energy in the process. This energy travels through space and reaches Earth in about 8 minutes, warming our planet and enabling photosynthesis in plants, which is essential for producing oxygen and food. The Sun's gravity is also crucial. It keeps the planets in their orbits, creating a stable environment that allows for life to thrive. Without the Sun's gravitational pull, Earth would drift into the cold void of space, making life impossible. Furthermore, the Sun experiences solar cycles roughly every 11 years, where solar activity varies from quiet to highly active phases. During active phases, solar flares and coronal mass ejections can occur, sending bursts of solar wind toward Earth. While beautiful, these solar phenomena can also affect our technology. Understanding the Sun helps scientists predict space weather and its effects on our planet, further emphasizing the importance of gravity and solar energy in maintaining our environment. First up is Mercury, the closest planet to the Sun. Mercury is a small, rocky planet with extreme temperatures. During the day, it can reach up to 800 degrees Fahrenheit, while at night, it can drop to minus 330 degrees Fahrenheit. Mercury has a heavily cratered surface, much like our Moon, and it has no atmosphere to protect it from impacts. Mercury's weak gravity, only about 38% that of Earth's, contributes to its inability to hold onto an atmosphere, which is crucial for protecting a planet from temperature extremes and space debris. Because of this, any potential for life here is virtually non-existent. The lack of atmosphere means no weather or water, essential ingredients for life as we understand it. Additionally, Mercury's proximity to the Sun results in harsh solar radiation that further complicates conditions for life. The Sun's intense heat and gravitational pull create unique day-night cycles and extreme temperature variations that make it a challenging environment for any form of life to exist. Next, we visit Venus, often called Earth's twin because of its similar size and composition. However, Venus is very different. It's shrouded in thick clouds of sulfuric acid, creating a runaway greenhouse effect that makes it the hottest planet in our solar system, with surface temperatures around 900 degrees Fahrenheit. Its day is longer than its year, taking about 243 Earth days to rotate once. Venus's gravity is about 91% that of Earth's, which is strong enough to hold onto its thick atmosphere, but it's this very atmosphere that prevents the planet from supporting life. The extreme pressure and temperature conditions are not suitable for any known forms of life. The Sun's energy, trapped by the dense clouds, causes relentless heating, creating an environment far too harsh for life as we know it. Interestingly, despite its harsh conditions, scientists are investigating the potential for microbial life high in Venus's atmosphere, where temperatures are cooler. The gravity there allows for a thick atmosphere, raising fascinating questions about life in extreme conditions and how solar energy interacts with atmospheric pressure. Now let's return home to Earth, the only planet known to support life. Our blue planet has a perfect mix of water, atmosphere and temperature to sustain a variety of life forms. Did you know that about 71% of Earth's surface is covered in water? Earth also has a diverse range of ecosystems, from lush forests and vast oceans to deserts and polar ice caps. Earth's gravity is just right. It's strong enough to hold onto a stable atmosphere that contains oxygen and protects us from harmful solar radiation. This balance creates the ideal conditions for life to thrive. The sun's energy is essential for life on Earth, powering photosynthesis, which in turn provides food and oxygen for all living organisms. Additionally, Earth has unique geological processes, including tectonic plate movement, which shapes the landscape over time. These processes create habitats and influence climates, allowing for biodiversity. The delicate balance of elements and conditions on Earth, combined with its gravity and the sun's energy, allows countless species to thrive, showcasing the beauty of life on our planet. Next is Mars, known as the Red Planet. Its reddish appearance comes from iron oxide, or rust, on its surface. Mars has the largest volcano in the solar system, Olympus Mons, which is about 13.6 miles high. It also has the deepest canyon, Valles Marineris, stretching over 2,500 miles. Scientists are very interested in Mars because it has signs of past water and may have once supported life. While Mars's gravity is about 38% that of Earth, which affects its ability to retain a thick atmosphere, it still shows evidence of having liquid water in its past. Ancient riverbeds and lakebeds suggest that Mars may have had a warmer, wetter climate billions of years ago. Today, its thin atmosphere is composed mostly of carbon dioxide, making it a challenging environment for life as we know it. The sun's energy, although weaker on Mars due to its distance, still reaches the planet and influences its climate. Understanding how solar radiation interacts with the thin Martian atmosphere helps scientists learn more about the conditions for life. The search for microbial life continues on Mars, especially with rovers like Perseverance analyzing soil and rocks for signs of ancient life. Now let's zoom out to Jupiter, the largest planet in our solar system. Jupiter is a gas giant, made mostly of hydrogen and helium. It has a massive storm called the Great Red Spot, which is larger than Earth and has been raging for over 350 years. Jupiter has a strong magnetic field and at least 79 known moons, including Ganymede, the largest moon in the solar system. Jupiter's immense gravity, more than twice that of Earth's, plays a critical role in the solar system. It affects the orbits of other planets and even helps protect the inner solar system from comet impacts by capturing or redirecting them with its gravitational pull. This gravitational influence can create a more stable environment for life to develop on planets like Earth. Jupiter's moons, particularly Europa, have drawn significant interest from scientists. Europa is believed to have a subsurface ocean beneath its icy crust, and the gravity exerted by Jupiter may create heat through tidal forces, keeping this ocean from freezing solid. The energy from the Sun also reaches Europa, albeit weakly, creating a potential for conditions that may support life beneath its surface. Next up is Saturn, famous for its stunning rings. These rings are made of ice and rock particles and can be up to 175,000 miles wide but only about a mile thick. Saturn is also a gas giant with a similar composition to Jupiter, and it has at least 83 moons. Titan, Saturn's largest moon, is bigger than the planet Mercury and has lakes of liquid methane. Saturn's gravity, though less than Jupiter's, still significantly influences its moons and rings. The gravitational pull helps maintain the structure of its iconic rings, keeping them intact despite the vastness of space. The study of Saturn's moons provides insights into how gravity can shape geological features and affect atmospheres. Exploring Titan with its thick atmosphere and surface lakes raises intriguing questions about the potential for life in extreme conditions. The gravity on Titan allows it to retain its atmosphere, making it a key target for future exploration. Understanding how the Sun's energy interacts with Titan's atmosphere could provide valuable insights into the possibilities of habitability on moons far from the Sun. Uranus is unique due to its unusual tilt, which is about 98 degrees. This means it essentially rolls along its orbit. It's an ice giant, mostly made of water, ammonia and methane. Uranus has a faint ring system and 27 known moons, each with distinct characteristics. The planet's gravity plays a role in maintaining its ring system and influencing its moon's orbits. The gravitational interactions between Uranus and its moons create intriguing environments, leading to geological activity on some of them. For instance, Miranda, one of its moons, has extreme geological features that suggest a past filled with activity. Uranus's distance from the Sun means it receives much less solar energy, resulting in extremely cold temperatures. However, the unique tilt and gravitational dynamics may create interesting conditions for studying the potential for life in unexpected environments. Our final planet is Neptune, the farthest from the Sun. This ice giant is known for its deep blue color and strong winds, which can reach speeds of over 1,200 miles per hour. Neptune has a stormy atmosphere with visible clouds and dark spots similar to Jupiter's Great Red Spot. It has 14 known moons, with Triton being the largest. Neptune's gravity influences the dynamic and extreme weather patterns in its atmosphere, contributing to the planet's rapid rotation and storm formation. Triton, Neptune's largest moon, is fascinating because it orbits the planet in the opposite direction of Neptune's rotation. This retrograde orbit suggests that Triton may have been captured by Neptune's gravity, making it a unique case in our solar system. Triton also has geysers that spew nitrogen gas into space, making it one of the most intriguing moons for future exploration. The study of Triton's atmosphere and gravitational interactions could help scientists learn more about the potential for life in icy environments and the history of the solar system. Beyond the planets, we have dwarf planets like Pluto, Eris, and Ceres. Pluto was once considered the 9th planet, but was reclassified as a dwarf planet in 2006. Dwarf planets are smaller than the main planets and often found in regions like the Kuiper Belt and the asteroid belt. They are fascinating because they can have atmospheres and even moons. Pluto, despite its reclassification, remains a popular object of study. Its gravity is weak, making it difficult to hold onto a substantial atmosphere, which affects its surface conditions. However, the New Horizons mission in 2015 revealed a complex surface with ice mountains and potential geological activity, suggesting that it is far from a lifeless rock. Ceres, the largest object in the asteroid belt, is also classified as a dwarf planet. Its gravity allows it to maintain a weak atmosphere, and it has unique features, including bright spots that may be salt deposits left by briny water. Understanding these dwarf planets and their gravitational characteristics expands our knowledge of the solar system's history and the processes that shape planetary bodies. Speaking of moons, our solar system is filled with intriguing natural satellites. Europa, one of Jupiter's moons, is covered in ice and may have an ocean beneath its surface, raising hopes for potential life. Enceladus, a moon of Saturn, also has water geysers that shoot into space, providing exciting areas for future exploration. Many of these moons exhibit geological activity, which makes them key targets for studying the potential for life beyond Earth. Europa's icy crust and the possibility of a subsurface ocean make it one of the most promising locations for astrobiology. The gravitational interactions between Jupiter and Europa may create enough heat through tidal forces to sustain liquid water beneath its surface. Enceladus, with its geysers spewing water vapor and organic molecules into space, provides a glimpse into what lies beneath its icy surface. The Cassini mission has already given us valuable insights, and future missions will focus on understanding the conditions that could support life in such extreme environments. The exploration of these moons highlights the diverse possibilities for life in our solar system, all influenced by the gravitational forces at play and the Sun's distant energy. From the fiery Sun to the icy realms of Neptune, our solar system is a wondrous place full of mystery and beauty. Each planet, moon, and celestial body plays a part in the grand design of the universe. As we continue to explore, who knows what incredible discoveries await us? The more we learn, the more we realize how much there is still to uncover about our cosmic neighborhood. Exploration efforts, both current and future, promise to deepen our understanding of these distant worlds. With missions planned to Mars, the icy moons of Jupiter and Saturn, and even beyond, the quest for knowledge about our solar system is far from over. So, whether it's through telescopes, robotic rovers, or future human missions, the adventure of discovery continues. Thank you for joining us on this cosmic journey. Don't forget to like, subscribe, and hit the bell for more amazing content about our universe. Together, let's keep exploring the wonders of space.